Good afternoon. Here is today's lesson on section 7.3 and some word problems. So 7.3 is titled Use Functions Involving E. E is a new number that you guys are obviously not familiar with. It's called the natural base, and it's approximately this. So I tend to use 2.718 to approximate E. It's an irrational number, so you can't express it as a ratio of two integers. And it was discovered by a Swiss mathematician by the name of Leonhard Euler. So that's why we get the letter E, because it's the first letter of his last name. I'll show you how this number actually was discovered the next time we meet in class. But let's do some examples right now. And many of these examples are from the book. And they're pretty simple. Like here, you have to simplify the following expression. So that's just simply e to the 7th power. You just want to add the exponents. What do you think about this one here? If you said 4e, you're 100% correct. Because 12 divided by 3 is 4, e4 over e3 reduces to e1. Then here you want to distribute the squared. So you have 5 squared times e negative 6x, because you got to multiply the exponents. So you have 25 e negative 6x. Or if you like, you can write as 25 over e 6x. That also works too. So pretty simple stuff. Just for dealing with a new number here. Now here we want to use a calculator. What you want to do is you want to do second ln. ln's on the left side of the calculator. So if you do second ln and then 4, that will get you e to the 4, which is roughly equal to 54.598. And we'll do 3 decimal places. If you do it for negative 0.09, you should get 0.914. Again, really simple stuff. We'll see the more practicality with E or natural base later in chapter 7. You can also graph these two. These do seem kind of weird to graph, because really what you're doing is you're graphing y equals 2.718 raised to the x power, which is obviously a nasty number. But let's say we plug in 0 for x. Then we get y is 1. So this graph will be for the first equation, y equals e to x. So if I put in 0, and the 0 power is 1, if I plug in 1, I get e, which is about 2.7, right? By the way, February 7th is also considered Euler's Day, and there's actually going to be a really big math contest that day, so I'll talk about that with you guys later this week. So the graph will look like this. Asymptote will still be the same place as we've had for some other functions. Domain is still all real. Range is still y is greater than 0. And it is a growth function because the base is larger than 1. Our base in this case is 2.718, obviously. For our next one, y equals e negative 2x. That's like saying 1 over e to the 2x, or 1 over e, then raise that to the 2x power. If you think about 1 over e is 1 over 2.7, right? So this will wind up being a decay function, if you think about it, because your base is less than 1. Plug in 0, still get 1. If I plug in 1, I get 1 over e squared, which is actually a pretty tiny number. What is it approximately? Of course, you'd have to use a calculator for that, but it would be about 0.135. But the bottom line is, you know it's going to drop, because if you plug in negative 1, we would get e squared, which in that case would be 7.389. I'll never ask you guys to do this in a non-calc section of a test, but just wanted to show you how it just still behaves the same way as a lot of our other functions. So you get y equals 0 for the asymptote, domain is still all real, and range is still y greater than 0. Now we're at the word problems. This will take a little bit of time to do, so I'm going to actually make a second part to this video because the bell's going to ring in 3 minutes, and obviously I don't want students coming in while making a video. So I will make a second part, so for tonight's homework you'll be watching 2 videos. And the second part should only be about a few minutes long. But yeah, I will talk to you guys later. Bye.